Here you can see all of my working out for part A of this question. I'll just talk you through it. So we are proving this identity, and we're told to do that by rewriting the cos 3x as cos 2x plus x. So in the top right hand corner here, I've taken the cos addition formulae from the formula sheet, and we're going to have the 2x is going to be the A part. So we're going to have 2x here and here. So that's why we've got the cos 2x at the front here and the sine 2x over here. Then we've got the x is going to be the b part of this. So that's why we've got the cos b here, the cos x there, sorry, and the sine x there. Right, next steps. We need to get rid of these double angles. And you can see over here that I have written down the double angles for sine and cos. You need to know these things. So when we've got this cos 2x at the front here, there are three different versions I can use. As you can see, I've chosen to use this version. The reason why I did that is I want to have my answer only in terms of coses. I don't want any sines at all. The sine 2x, there's only one way I can rewrite that, which is with the 2 sine x cos x. Next, I've expanded the brackets. So I've got the 2 cos squared x times cos x is 2 cos cubed x. I've got the minus 1 times cos, which is minus cos. And then I've got the sine x times sine x, which is sine squared x, which I have then rewritten to be 1 minus cos squared. Because like I said before, we don't want to have any sines involved in this identity at all. I've then multiplied those brackets out. So the minus 2 cos x times 1 is minus 2 cos x. The minus 2 cos x times minus cos squared is a positive 2 cos cubed x, which I've then grouped together with the other 2 cos cubed to get 4 cos cubed. And I've got the minus cos x minus 2 cos x, which is minus 3 cos x. And as you can see, we have proved that identity. So that's part A done. Moving on to part B. So it says hence. So I'm going to be using what I've just done in part A. So using this identity. And I'm looking at the equation I've been told to solve here. And this 8 cos cubed x minus 6 cos x, I'm noticing that that is double what I had in part A. So that I can replace that with double the cos 3x. So I'm replacing it with 2 cos 3x. The plus 1 is still there. The 0 is still there. I'm then subtracting 1 from both sides. And then dividing both sides by 2. And so I've got cos 3x is equal to minus a half. I've then done cos inverse of minus a half, and that's giving me my first solution of 2 pi over 3. I then am going to use the graph to work out all of the other solutions I might need. As you can see, I've drawn quite a big graph. I've gone all the way up to 6 pi rather than just 2 pi. And the reason for that is because these are going to be the values of 3x. And I know I'm going to need to divide those by 3 in a minute. So that's why I've drawn the graph all the way up to 6x. 6 pi rather. So here's the minus 1/2. Here's the first solution of 2 pi over 3. So the next solution is going to be 2 pi minus 2 pi over 3. So that's where the 4 pi over 3 came from. The next solution is going to be 2 pi plus 2 pi over 3, which is where the 8 pi over 3 came from. The next solution is going to be 4 pi minus 2 pi over 3, which is where the 10 pi over 3 came from. The next solution is going to be 4 pi plus 2 pi over 3. And the final solution is going to be 6 pi minus 2 pi over 3. So these are our 6 solutions for 3x, and then you can see that I've divided all of those by 3 to get the solutions for x.